All right, welcome back. Welcome back to Math is Easy. Step by step. I like to go over some of the rules and examples of converting standard form into scientific notation. And I'd also like to give you an opportunity later to pause and practice some problems, and I will go over the answers with you. Okay, so standard form into scientific notation. The rule. So remember, you're going to be converting really large numbers or really small numbers when you're converting from standard form into scientific notation. So you'll be moving the decimal one direction or another in order to create a number between 1 and a number that's less than 10.0. So the rule is you want to move the decimal to create a number between 1.0 and a number that is less than 10. 9.99 is an example. So here you can see some examples that fit that rule. You have to keep in mind you want a number between 1.0 and a number that's less than 10.0. And so here are some examples. 1.0 is okay. You can have a number 1.0. 1.3, coefficient of 1.3 is okay. Another coefficient of 7.2, yes. Is that number between 1.0 and smaller than 10? Yes, it fits that definition. 9.99, yes, that coefficient would work. It's larger than 1.0 and it's less than 10.0. And 4.2 also fits that criteria. When you're converting these coefficients, you want to convert them into a number that's between 1.0 and smaller than 10.0. Now, here's some examples of no, right? 0.3. That number's smaller than 1.0. That coefficient does not work. 0.99. Again, smaller than 1.0. That will not work. 10.2 is larger than 10. That will not work. 11.3 and 10.0 is still too large. It must be a number smaller than 10.0. These are rules for converting that coefficient number. All right, so now I'd like to go over some examples, standard form into scientific notation, right? So there is an additional rule we have to follow, and that rule is if you're moving that decimal from the original coefficient to create a new coefficient, and you move that decimal to the right, then you'll be adding a negative exponent into that scientific notation form. Okay, let's go over an example. I have 0.00000173. That's a super small number. I want to convert that into scientific notation. And remember, I'm going to create a coefficient between 1.0 and 9.99. So in order to create that coefficient between 1.0 and 9.99, I move this decimal to the right 1, 2, 3, 4, 5 times. I ask myself, is 1.73 between the number 1.0 and 9.99? Yes. And the rule is, again, you move that decimal to the right, it's going to be a negative exponent. How many times did I move this decimal to the right? I moved it 5 times, so it's a negative 5 exponential value. And what was my coefficient now? My new coefficient is 1.73. I'm going to put that 1.73 new coefficient right in front of that times 10 value. And again, when you move the decimal to the right 5 times, it's going to be a negative 5. Because again, that's the rule. You move it to the right, however many times you move it, that's your exponent value. You move to the right, it's a negative exponential value. Okay, let's go over another standard form in the scientific notation rule. Okay, if you move that decimal to the left to create that new coefficient between 1.0 and 9.9, then there is a slightly different rule when you move that decimal to the left. So if you move the decimal to the left to create that new coefficient between 1.0 and 9.9, then you will add on a positive exponent to your scientific notation power of 10. So let me show you this example here. Okay, so remember, we want to change this super large number, which is 257 million, into a smaller number between 1.0 and 9.9. I'm going to take the invisible decimal here to the right of the ones place and do that. I'll move it however many times I have to get that value between 1.0 and 9.9. Well, let me see. Is 2.57 the new coefficient? Is that between 1.0 and 9.99? Yes. So it fits that rule. Well, how many times did I move it to the left? Well, 1, 2, 3, 4, 5, 6, 7. I moved it 8 times. And again, if you move that decimal to the left, you're going to add on a positive exponential value to that power of 10. So my new coefficient is 2.57 times 10 to the positive 8 value. All right, we got some examples here. I'd like you to look at these and pause the video and give these a try yourself. And I will be right back with the answers and the instructions on how to get those answers. So 0.00029. You want to convert that into scientific notation. You have 30 million. You want to take that value, write it down, and practice your conversion. And then we have 0.000000351. You want to convert that number into scientific notation. Pause the video, give a try now. I'll be right back with the answer. All right, welcome back, welcome back. So we took the decimal. We need to create a number between 1.0 and 9.99. So I take that decimal, I move it to the right 1, 2, 3, 4 times. I got a number that's 2.9. Is that between 1.0 and 9.9? Yes. So I stop moving the decimal at that point. That's my new coefficient, 2.9. The times 10 will always be there. And how many times did I move it to the right? 1, 2, 3, 4 times to the right. Remember, when you move the decimal to the right, that's a negative exponential value. 2.9 times 10 to the negative 4. All right, here's the next example problem. We had 30 million. We show this invisible decimal, right? We'll always have that times 10 down here in scientific notation. And how many times do I move the decimal to get a number between 1 and 9.9? 1, 2, 3, 4, 5, 6. I moved it 7 times. Is 3.0 between 1.0 and 9.99? Yes, it is. So that's my new coefficient, 3.0, just 3, times 10. Remember, you move it to the left, it's a positive exponent to the power of 7. All right, final example. We're going to move this decimal until we get a number between 1.0 and 9.99. I move it 1, 2, 3, 4, 5, 6, 7. I move it 8 times to the right. Is 3.51 a number between 1.0 and 9.9? Yes, it is. So 3.51 is my new coefficient. Times 10 will always be there in scientific notation. And remember, when you move that decimal to the right, it's a negative exponent. We moved it 8 times, so it's a negative 8 value. Thank you for joining me. If I've helped you, please help others. Stick with this. I'm going to go over all the information I gave you in the table of contents video. This is only a small portion. Math is easy. Take it step by step. If I've helped you, please help me like, follow, and share these videos.